Hello dear students, I am Devashish Saho from DePaul School, Berhampur, and we are going to discuss an important chapter of chemistry for class 10 students, that is acid, bases and salts. This is a continuation video of the same chapter, and in this portion we are going to learn about pH and what is a pH scale. Let us go into the video and watch what we have to study in this portion. First, we are going to discuss about the definition of pH. What is pH? pH is a measure of the hydronium ion concentration of a solution. We are going to discuss about the pH scale, the ionic product of water, indicators and various different types of indicators. And finally, we are going to discuss about the uses of indicators. First, let us discuss what is the definition of pH. pH can be defined as the negative logarithm of the hydrogen ion concentration present in a solution, which is generally expressed in terms of moles per liter. In this case, the logarithm is taken to the base of 10, and pH is regarded as a measure of the acidity or the alkalinity of a solution. That means if I want to know whether a solution is acidic or basic, or how acidic or basic it is, I can know from its pH. Water is a neutral liquid and has a pH of 7. When a substance is dissolved in water, then either it becomes acidic, basic or neutral. Acidic solutions generally have a pH less than 7, whereas alkaline solutions have a pH which is greater than 7. Neutral solutions have a pH of 7. If a solution has a pH very less, that is between 0 to 3, then it is considered as a strong acid, and if it is having a pH between 5 to 6, it is considered as a weak acid. Similarly, if a solution has a pH between 10 to 11, it is considered as a weak alkali, and if it is having a pH which is between 13 to 14, we consider it as a very strong alkali. So by knowing the pH of a particular solution, we can say whether it is a strong acid, strong alkali, strong weak acid, weak alkali. Ionization of water. We all know that water dissociates to form H plus ions and OH minus ions. At a temperature of 25 degrees centigrade, pure water dissociates to form 10 to the power of minus 7 moles per liter of hydrogen ions and 10 to the power of minus 7 moles per liter of hydroxyl ions. This is true only for pure water which undergoes 10% ionization, whereas in case of others, this will not continue. So pH can be regarded as a measure of the hydronium ion concentration. The scale for measuring the hydronium ion concentration in any solution has to cover a wider range. That means it should be able to measure a lot of different type of solution with a lot of pH. So basing on the concentration of H plus ion and a logarithmal scale which covers the factors of 10, pH can be found out for various solutions. P stands for power and H stands for hydrogen. So we can consider pH as the power of hydrogen, and pH can be mathematically said as the minus of log of H plus ion concentration. pH is defined as the negative logarithm of H plus ion concentration. So if the pH of a solution is 1, that means the number of hydronium ions present or the concentration of hydronium ions in that solution is 0.1 moles per liter, or 10 to the power of minus 1. If it is having a pH of 3, then hydronium ion concentration is 10 to the power of minus 3, or 0.001 moles per liter. If it is having a pH 7, then similarly it is having a concentration of hydrogen ions or hydronium ions as 10 to the power of minus 7 moles per liter. So how are we going to find the pH? So to know the pH, we have to take the negative logarithm of the hydronium ions present in a solution, or the concentration of hydronium ions is equal to 10 to the power of minus pH. So we can say that pH is a measure of the hydronium ion concentration present in a solution. Then the same equation can be also used for hydroxyl ion also. So we can say that POH is equal to minus of log of OH minus. So pH plus POH is equal to 14. The entire pH range is covered by this equation. So always remember, a solution which contains H plus ions and OH minus ion, we can calculate the pH. Kw is considered as the ionic product of water. Water's ionization constant is Kw, which is equal to H plus the product of H plus ion concentration and OH minus ion concentration. We all know that in pure water the concentration of H plus is 10 to the power of minus 7 and OH is also 10 to the power of minus 7. That means equal amount of H plus and OH are given out. So ionic product of water is 10 to the power of minus 14. So 10 to the power of minus 14 is regarded as the Kw or the water's ionization constant. Now, we all know that pH plus POH is equal to 14. So, if we take the negative logarithm of the H plus ion concentration and the OH minus ion concentration, then it will come to 10 to the power of minus 14. So, pH plus POH is equal to 14. So, simply we don't need to go to this complicated definitions. We just need to remember that pH is the negative logarithm of the hydronium ion present in a particular solution. Now, if a solution is having a lot of H plus ions, that means it is having a low pH, and if it is having a lot of OH minus ions, then it is having a high pH. So, if the range of pH is between 1 to 3, then it will be a strong acid. 4, 5 and 6, it will be a weak acid. 7 is neutral, 8 to 10 is a weak alkali, 11 to 14 is a strong alkali. So, by knowing the pH, you can say whether a particular solution is strong or a weak acid, or a strong alkali or a weak alkali, or it is a neutral solution. Now let us discuss about the pH scale. If we know the pH of a solution, then what does the pH scale tells us about, or how to measure the pH? We are having a pH scale, which is a measure of the relative acidity or alkalinity of a solution. The pH scale ranges from 1 to 14, in which the pH 1 to 6 is acidic in nature, 7 refers to a neutral solution, whereas 8 to 14 refers to an alkaline solution. This scale is based on the definition of pH, that is pH is equal to minus of log of hydronium ion concentration. If we know the pH, then we can know the amount by knowing the concentration of the hydronium ions, we can decide the scale. So the acidic solution, in them the molar concentration of hydronium ion is more, whereas in case of the basic solution, the molar concentration of hydroxyl ion is more. So more the number of hydroxyl ion, higher will be the pH, and lesser the number of hydronium ion concentration, then lesser will be the pH. So acidic solutions will have a pH value below 7. A solution with a pH of 0 means it is highly acidic. 0 we don't have. 1. A solution of a pH of 7 is neutral. Pure water has a pH of 7. Alkaline solutions have a pH value above 7. A solution with a pH of 14 is considered as highly alkaline in nature. So, by knowing the pH, you can say whether a solution is acidic or alkaline. pH is very useful in our day-to-day life, as many common reagents which we are using in our day-to-day life, and their pH range helps us to decide several different type of things. For example, gastric contents have a pH of 1.6 to 3, soft drinks with a pH of 2 to 4, lemons, vinegars, tomatoes, pH ranges from 2 to 5. Human urine has a pH which is varies from slightly acidic to slightly alkaline depending upon our food pattern. Saliva has a pH of 6.5 to 7.5. Human blood has a pH of 7.4 generally, but it ranges from 7.3 to 7.5. Milk of magnesia, magnesium hydroxide, 10.5. These substances which are available, all these substances helps us to know the pH of the substances, helps us to decide the various different type of chemical processes which are happening in our body. So it is very important to know the pH of the solution. Now let us discuss about the pH graph. What happens when we add an acid to an alkali? When we add an acid to an alkali, the pH of the same decreases, and if we add an alkali to an acid, then the pH of that gradually increases. It is because of the increase in the amount of hydronium ion concentration or increase in the amount of hydroxyl ion concentration. Now let us discuss about the indicators. What are indicators and what is their use in chemical laboratory? We all know that if I want to know whether something is an acid or base, then we need to use an indicator. Weak organic acids or bases that change their color when we add it to an acid or base is known as an indicator. For example, phenolphthalein, methyl orange, bromothymol blue, litmus solution, or red cabbage, all these are different types of indicators. These indicators change their color when we add them to a solution which is either acidic or alkaline. So, an indicator is used to check if something is an acid or base. Then how are we to measure the strength of an acid or a base? There are two different types of indicators. One of them is an acid-base indicator, for example the litmus solution, and the other one is a universal indicator. An acid-base indicator tells us only if something is acidic or basic, whereas a universal indicator helps us to know the exact strength of the acid or the base. So, acid-base indicators are generally the compounds when we add it to a solution, they check if the compound is either an acid or base, but they are unable to tell us whether it is a strong acid or a strong base, or it is a weak acid or a weak base. So, they do not tell us about the strength of the solution. Here we are having a table representing various different types of indicators. Methyl orange, in acidic solution it is red, whereas in an alkaline solution it is yellow. Bromothymol blue is yellow in acidic solution, whereas it is blue in alkaline solution. Phenolphthalein is colorless in an acidic solution, red in an alkaline solution. Litmus, we all know it is red in an acidic solution and it is blue in case of an alkaline solution. Litmus solution, a commonly used indicator in the laboratory. Most often we have seen this. Litmus solution is usually violet in color, and when this litmus solution is added to a solution which is acidic in nature, it changes its color to red. And if we add it to a solution which is alkaline in nature, then it changes its color to dark blue. So by seeing the change in color, we can just say whether the pH is acidic or the pH is alkaline, or if it is neutral, then the litmus solution does not change its color, it remains violet as it is. Then coming to phenolphthalein. Phenolphthalein is also an important indicator. The color changes from colorless to pink. The numbers given are the pH on the test tubes. You can see that from colorless, gradually the color changes to pink as the pH changes from 3 to 11. So, phenolphthalein indicator is important. Methyl orange, another such indicator, it changes from red to gradually to orange. As the pH increases from 3 to 11, you can see that the color change is from red to orange gradually. For acidic solution it is red, and for alkaline solution it is orange in color. Bromothymol blue, another such indicator, its pH it goes from low pH to high pH, then here the color changes from yellow to gradually blue. Now we come to the universal indicators. What are universal indicators? Universal indicators are nothing but these are a group of compounds which help us to know the particular pH of a solution. It tells us about the strength of a particular solution, whether it is strong acid or strong base, weak acid or weak base. So it is very important in various chemical processes to know the exact pH of a particular solution. Universal indicators are have a widespread use in chemical laboratories because they change their color according to the specific pH value of the solution. They thus help us to know about the strength of an acid or a base. We are having many different type of pH universal indicators. pH paper is a common example. We are having a standard, and by putting the pH strips into the solution, we cross check the color change with the standards, and then we find out the exact pH of the particular solution. Here you can see the change in colors of the pH paper when they were put in various different solutions of different pH range, and you can see the various colors over here, red to orange, then green, then blue to violet. By matching this color with the standard, we can know the exact pH of the solution. They are very important in the chemical laboratory. Every chemical laboratory has pH paper strips to know the pH of the solution. Now, what are the limitations of an indicator? Solutions must be colorless. Indicators cannot show the change in the color unless the solution is colorless. If it is already colored, we cannot know the change in the color. Moreover, the eye must be able to detect the change. Sometimes the change in the color is very less significant, so we need to know the change. Now, what is the difference between an acid-base indicator and an universal indicator? As I already said, acid-base indicators are generally single compounds which change their pH on a particular range, whereas the universal indicators are a group of compounds which generally change their over a wide pH ranges from 0 to 14. With the help of an acid-base indicator, we can know only whether it is acidic or basic, whereas with the help of universal indicator, we can know whether the exact strength of the particular solution, whether it is a strong acid, strong base, weak acid or weak base. Here the individual chemical components are there. There we are having several chemical components. Now we come to hydrolysis. We all know that when a salt is added to water, then the salt breaks in water to form the respective acid and the alkali. Now let us recall the strong acids. HCl, HNO3, H2SO4, these are a group of strong acid, whereas all the group 1A hydroxide are considered as the strong bases. Now whenever a salt dissociates in water, then we can know whether the solution is acidic or basic depending upon the parent acid and the parent base. For example, if a particular salt is neutral in nature, then the parent acid is strong and the parent base is also strong. If it is acidic, then the parent acid must be strong, whereas the parent base is weak. If it is alkaline in nature, then the parent acid is weak, whereas the parent base is strong in nature. So the salt solution's pH depend upon the strength of the parent acid or base. Here a few examples are given. For example, aluminium hydroxide and HCl will give aluminium chloride as the salt, and here the solution will be acidic in nature because HCl is strong. For the second one, the solution will be strongly basic because barium hydroxide is a strong base. For the third one, KOH and H2SO4, K2SO4 will be slightly acidic in nature because sulfuric acid is a strong acid. When ammonia dissolves in water, it forms ammonium hydroxide. It consists a large number of hydroxyl ions, so definitely it will be a slightly basic in nature. So now coming to the importance of pH. Now pH, as we have already studied so many different things about it, so is an important use in various different fields. First, coming to agriculture, by knowing the pH of the soil, we can check the fertility of the soil and the plant which can grow in a particular pH can be decided. Food preservation, for the food preservation, pH is very important. Enzymes degrade at a particular, if they are not at a particular pH. Similarly, for the preparation of medicines, medicine preparation can be done if at a particular pH, and if the pH is high or low, then it will degrade. Analysis, qualitative and quantitative, also requires the knowledge of pH. Also in various different types of compounds which are shown in this list, all the pH which are given, an idea of this helps us to know about the various chemical processes that we are going through in our day-to-day life. For example, all the human body processes are carried out at the human blood pH is 7.5. Similarly, detergent works at a pH of 10. Baking soda requires a pH of 8.5. Rainwater has a pH of 5.5. Now coming to the pH in the digestive system. You all know that the pH of the mouth is around 7. Saliva has a pH of 7.4 because it contains an enzyme, salivary amylase or ptyalin, that breaks the complex carbohydrates into simple sugar. Stomach has a pH of around 1.2 to 2, which is responsible for catalyzing the breakdown of proteins with the help of the enzyme pepsin, while small intestine has a pH around 8. This is for the gradual process of digestion. Thank you so much for watching the video. Please watch the continuation video of the same for knowing about acid rain. Hello dear students, I am Litmus Solution from DePaul School, Barampur, and we are going to discuss an important chapter of chemistry for class 10 students, that is acid.